So, who doesn't like some late night math? I figured now would be any better time than ever to do a little math and some research that I just put together based on the antibody testing that's been going on in New York, because it's been randomized, and that is going to give us a really good advantage to the numbers. This has all been a numbers game. It's either scary or promising, so let's get to it. Antibody test specificity of 96 to 98%. So let's put that first here. So that means there's a 2 to 4% error. Wow, that is super tiny. I'm gonna have to write bigger for the rest of this. Okay, now we have a population in New York has been tested, and the percent that has been tested has been randomized. 19 to 21% of NYC. That is a really sloppy NYC, but you know, hey what? New York City's sloppy. Sometimes, not all the time. Love that city. So nobody has immunity. This is showing that people have had it, possibly, likely immune, but the thing that really what we need to know is what percentage of the population has had it and what percentage of the people that are dying. So we have 19 to 21% in New York City. If you look at a map, you're like, well, New York City is 18 million people, or New York City is 8.3. And if you look here, that is New York City Metro, which is 18.8 million. But the map that is shown in the New York Times is New York City. So that's 8,399,000 people. And now we have the current death rate. And of course the death is lagging behind by about 3 weeks with everything else, but let's just NYC. Now, what we want to figure out is how do these two numbers compare? Well, if it's a 96 to 98% accuracy, let's just use the low end. Specificity times random testing, we'll just say it like that, times NYC population, and we're going to take the deaths and we'll divide the deaths by that. So now we have 19,438 divided by antibody testing times random testing, let's say the high number there, so we're giving everything the benefit of the doubt, and then times the New York City population. When you put these numbers together here, 1,693,238 New Yorkers that have already been infected, divided by the 19,438 that I'm sure people will debate that number because every death is a COVID death, but we'll find out later. But let's just, once again, for number's sake, push on the high end of that just so we can get a more beneficial number rate, because we can't just, it's within this number somewhere. Means the mortality rate, which is what we were calculating here, is 1.15. 1.15%. And there you have it. That's the mortality rate of this disease. Now, that is if people continue to get that. So now what percentage of the population is going to be affected by that? That's the next step. We go to the R0 rate. Is somewhere around 2.0 to 2.5. This is directly related to social distancing and everything else. Obviously, social distancing brings that number lower. That means for every one person that has the infection, 2 to 2.5 will get infected. Of course, social distancing, for every one person that gets infected, it's less than 1. But if there is no social distancing, this is the number. Now, that's for COVID. Now, the flu, on average, is somewhere around 1.28 or so. So that means that COVID is equal to about 2 times the amount of people that get it. So on average, in the United States at least, about it's a lot of abouts here. We have 10 to 40% of the population gets the flu every year. And by the way, every year means flu season, which is actually like about 5 to 6 months. So 10 to 40%. So if this is twice the R naught, that means COVID equals 20 to 80%. I need to correct myself, and that's important. The flu infects 5 to 20% of the population. That's what I had to say here. The flu, I remember those numbers are somewhere. It's a little late, my head's a little kooky. 5 to 20% is flu. 10 to 40% is COVID. So that means 10 to 40% of the population could get infected in just the United States, or actually the whole world in general. Now, applying that to these New York City numbers, we can say there's 330 million people in the United States, roughly. And out of that number, you have 10 to 40% that would get infected, and 1.15% of those that would get it. So on the low end, with no social distancing, and by the way, we're doing great with social distancing, but we have to do that all the way until there is a vaccine or a treatment. But if there's a treatment, that still means that people are going to get infected. So that's about 15 months down the road. And remember, once we have a vaccine, that doesn't mean everybody has it. That means that you need to vaccinate 7.8 billion people. They can't get vaccinated within a day. 330 million people in the United States means even if we vaccinate 1 million people a day, that's still going to take 330 days to vaccinate the whole country. Hopefully we can do more than that, but 1 million a day getting vaccinated is still very high. So let's say about 15 months. So in 15 months, will we stay in our homes for 15 months? Probably not. So that means that the social distancing measures are probably going to drop, and the R naught rate is going to increase. Probably not to these numbers, but somewhere higher, still higher than the flu. And that means that on the low end, over the course of the next 15 months, including the deaths that have already happened, you have, on the low end, 378,832. And on the high end, that would be times 4. You have to 1,515,000, whatever, 330, just for numbers' sake. Okay. Those are the numbers of what is likely to happen over the course of that period of time. That's math. So what can we do? What can we expect? We can expect, we can expect that somewhere between 10 to 40% of the population will get infected. Now, in order to reach herd immunity, everyone's talking about herd immunity would be not that great. It wouldn't be a good idea, because if this is correct, which is that this seems to be more and more correct because of the antibody tests. 1.15% is roughly where we're looking at the death rate, which is The flu is 0.128 or something like that. So basically 1,000% deadlier, which is still very small, only 1.15%, but 1,000% higher than what we're used to. So that means that if we have these numbers, to get herd immunity is like 50 to 80, let's just say 60 to 80% of the population, and that's what people equals herd immunity. Now, what that means, of course, if anyone's familiar, you have, you know, a bunch of people in a group, and if you have a barrier, and these people are the 60%, and then there's others, they cannot be infected because the people in between are stopping. That's what herd immunity means. Just a little run up there. So let's just say in the low end 60%, now we're running into these issues again. To get to 60%, that's 6 times the low end number. So 378, 832 times 60%. So in order to do that, at a minimum, 2,272,000 people in the United States alone would have to lose their lives. That's very unfortunate. We don't really want that to happen, especially globally. If you look at it on a global scale, to reach herd immunity, that means that 60% of the world would need to contract this, and we wouldn't really want that either, because you have 7.8 billion people. So we're just gonna do those numbers real quick. Times 60% times the 1.15%. That means, unfortunately, 53.8 million people, 53.8 million would have to die, and we don't want that. That's not good. Even though people are like, yeah, let's, you know, herd immunity, yay. So 57 million people die a year. So that's getting close to 100% more deaths than average. That's just not good. So what can we do? How do we solve this? It's going to be more than just these numbers. This we can't do much about. We can maybe drop this number, the mortality rate, with treatment. And we can also probably drop it with finding that intubation perhaps is not the correct method. Also administering types of treatment early, that's been proven to be successful. There's still testing going on with the chloroquine and hydroxychloroquine and other methods like that, but what's been found with the negative testing, where more people have been dying than not, is that when people are on the edge of death, they administer these emergency, hydroxychloroquine, for instance, and then they die. But it's if you could relate your body to a house and there's a fire. If you have a small fire and you use a fire extinguisher, it's going to put that fire out. If the whole house is on fire and then you use the fire extinguisher, it's not going to put the fire out. So that's basically why people are like, oh, it doesn't work. Well, I feel like what we need to do there is try it on people that have the early onset of the symptoms, and that might reduce that number. To reduce the R0, we can do that with social distancing, not this extreme, because we can't continue the economy that way. So we can look at countries like Sweden and Taiwan, South Korea, Japan. What are they doing? They're wearing masks. We're wearing masks now. That's actually reducing that R0. Also, a few other things. I actually think that if we continue to follow, like Sweden, for instance, they're keeping their businesses open and they're able to still keep that R0 number low. Correlated to Michigan, Michigan's more densely populated, but Sweden and Michigan are about the same population size, and Sweden has a lower number of deaths than Michigan right now. That's in part from population density, it's less dense, but on top of that, it's and culture. But if we follow that, that's a little bit more social distancing and continue the economy open, we can reduce that number. Treatment, we can reduce that number. And random testing, actually not random testing for the antibodies, but random testing for the virus itself, and contact tracing with, I mean, we all have, I was looking for my phone, it's right there. We all have that in our pocket, and everyone's like, if you get a vaccine, there's gonna be some tracker in your body and it's gonna be crazy or whatever it might be. That's already tracking you. Okay, so we already have it, and it's selling us, you know, lights, and it's selling us whatever else we want. May as well use it to save our lives, because it's already literally there. So let's just implement it to save our lives, and it's already something that's there. That is probably going to do a lot to decrease this number. I don't think we will ever see a death rate of 53 million people in the world dying from this. I think that we won't see a death rate in the United States of 2.2 million. I think that what's going to happen with opening things up, people will realize that we're going to be between these two numbers here, between 370,000 and 1.5 million. It's very unfortunate, but it's math. It's what happens when you do antibody testing. Its specificity, which is quite accurate, 96 to 98%, with the randomized tests, that's what you get. Now, this number, people might argue, is too high as well, the death rate. But the thing is, the average death rate for all of these countries and all of these cities, based on historical averages, is already much higher. So even if they are or aren't labeling, the total death rate tells the true story. Because that doesn't mean, there's not a bunch of people just having shoehorn mishaps and, jumping into moving helicopter blades to increase that number. It's just, that's the number, and there's no way to cut that one differently. So there you have it. That's the most accurate that I can come up with at 1 a.m. And cool. Well, time for bed.